Okay, so I'm going to talk about Fable, the forecasting framework that I worked on in order to improve a lot of the shortcomings that we saw with the forecast package that Rob just mentioned. So again, to start, a little bit of a recap into the history of forecasting, at least in R. It started back in the start of the new millennium with the TS package in R, and we've just heard some of the details of TS and the shortcomings of it, so I won't dwell on it. But with this, we also had the basic models starting to come up. So the first ARIMA models, the Kalman filter, a lot of the foundations that we use were quite good already back then. Then Rob, with a lot of his consulting, worked on the forecast package and developed a lot of these alternative models that you could use for forecasting. Then he employed me, which was quite fortuitous for me, and I started with a lot of bug fixing, but then my ambitions and my tastes started to grow substantially, and I felt like there was something seriously wrong with the forecast package, with its inconsistencies. So I set out to improve that, but before I could do that, we had to work on the data structure. And as we'll see, when you're working with a forecasting workflow and building a framework for forecasting, you need a strong foundation. Every future step from data is influenced by the start, and you build on top of the foundation in order to develop a good design. And without Sybil, it wouldn't be possible to create Fable. So with Sybil around, I created Fable to resolve a lot of issues in the forecast package, and shortly after, we retired the forecast package. But it's still very widely used, so of course we still maintain it. So mostly what I want to talk about today is design, and design of forecasting software specifically, because it involves a lot of very difficult decisions. And I think this is where a lot of the missteps went when developing the forecast package. Because there was no framework behind the forecast package, and each model tried to do its own thing and returned a complete model object or forecast object, had to do its own transformations, every step in the forecasting workflow, or at least a lot of them, needed to be rewritten every time you created a new model. And because it was rewritten, there was a lot of code duplication and a lot of code inconsistencies, and that caused a lot of the design issues that were just not solvable because it was so widely used. Now, choosing a good design is subjective, but there are some common patterns. Of course, you don't want it to be inconsistent. And a lot of this depends on the context that you're working in. So for me, working in R and trying to target the tidyverse, I would want to follow a lot of the design principles from the tidyverse to make it fit cohesively. But of course, if you're writing in Python, you'd want a more Pythonic approach. So when people ask me to try and copy exactly what Fable is and move it over to Python, I don't necessarily think that's the best approach. Because if you're using Pandas or other Python data manipulation processes, you'll be familiar with a different workflow. And this is also a consideration for developers. If you're able to contribute a new model, a new reconciliation technique, a new data type into an ecosystem, into a forecasting framework, then you can inherit a lot of the other things that have already been made for that ecosystem. So you don't have to create the accuracy methods or the plotting tools. You can inherit that from the framework and have this interoperability with other people's code. So I mentioned the tidyverse, and because I'm targeting the tidyverse, they recommend 4 guiding principles for designing your software. The first here is for it to be human-centered. And I think this is pretty standard for human interface design for computing across all languages. So whenever you've got inputs or outputs, they should be easy to read. Even though it's code, it should be fairly easy to read as natural language. Similarly, the output should be clear and easy to work with. More than that, not just output when things go right, but when things go wrong. If you've got an error along the way, give some hints. Give it human approaches for what went wrong or what's most likely, rather than the programmatic, unable to subset length out of range or something. Tell us what it means. Consistency, we've heard a lot about, Rob, with the inconsistencies of the forecast package, but working within a framework, you almost get consistency for free because you're building the consistency at the lower level, the foundation, so that all of the models that subscribe to this framework or work within this framework follow at least some basic rules of consistency. When we think about a workflow, composition comes to mind as well. So taking data as a completely separate process from modeling to forecasting, accuracy, plotting, etc. Having these separate composable tasks allows people to remix them in different ways that previously weren't imagined. I remember quite notably when I first released the Fable package and I did STL decomposition forecasting. The STLM model functions and forecast functions in forecast have a string. So you say, I want to do this with an ARIMA model, an ETS model, and there's no customization for exactly what those models are. In Fable is a bit different. You specify any model, and I've got a slide for this later. But I saw people put all sorts of crazy different combinations and specific models within it. You can do decompositions on decompositions and ensembles with the components. Having this compositional language around it allows the freedom for people to write the model that they need to suit their data, their specific problem. And also some freedom to make some mistakes as well. So that's where good documentation can be useful for guiding people in the right direction. So to summarize some of the main differences between the forecast and Fable package, forecast works mainly with individual time series, but Fable is designed to forecast at scale. Regular and infrequent observations for the forecasting package, so maybe quarterly, monthly, aggregated from there, whereas Fable allows any timestamp that you're normally used to working with in a database. So you can work all the way down to event level data, nanoseconds. It's completely free. And I think the main goal of the Fable package when we started designing it, it took about a year to design what we wanted to build before actually implementing, was the forecasting step. Of course, that's the most important process in this workflow, but there's a design problem with specifying the forecast intervals. So we wanted to make this complete distributions, and Fable does that. And lastly, the TS objects were starting to get limited, and the tidyverse at the time was starting to get quite popular, and we wanted something that allows time series analysis and forecasting within the tidyverse. So that guided a lot of our design principles and our composition of the framework. So if you've seen the tidyverse data analytics workflow before, where you start with importing data, cleaning data, visualizing, modeling, reporting data, etc., we came up with our own workflow for forecasting. And this was guiding us for the composition of different parts in the framework that we needed to develop. And each one of these steps is extensible, so that other people can build upon the framework, implement their new accuracy technique, and then still get the benefits of all the models, the forecasting, the plotting that exists. So there's a subtle difference here. We started by designing the forecasting workflow, but the forecasting framework design matches that exactly. So thinking about how we design the mental model for how you would implement the forecasts compared to how we think about it ourselves, we wanted a one-to-one mapping there. So here's a small example. We've got a data set that many of you are familiar with, the tourism data set, and I've aggregated this a little bit. But you can see, usually when you bring in data, it's in this rectangular data frame format. The TS object class works with the vectors, which is the first friction point that we wanted to resolve, and the Sybil package does this. We had so many students and questions online about what a frequency is. I think this is one of Rob's most successful blog posts. How do you find the frequency for the TS objects with many different combinations? So that's a pain point. The other limitation is if you wanted to do multiple time series, especially with reconciliation. The HTS package uses TS objects, and that's quite limiting because you need to have some symbolic name variable combination. And as you build up more different column names, so we've got business, holiday, other, visiting here. If I start to add in more dimensions, the full data set, region, state, and purpose, you can see I need to now separate these with underscores. And then what if I added a name, a value that had an underscore in it? You need to do string separation. It starts getting ugly very quickly. Okay. Now, the other thing with TS, which I wasn't too pleased with, wasn't actually the forecast package. It's back in 1999 when it was first released. It's the window function and these domain-specific languages for slicing and dicing and otherwise manipulating time. Window, I have a problem with because it's a specific function for a specific task. There's no generality here. If you already know how to cut a data set with indexing, they're encouraging you to use a different tool to achieve the similar thing. So the TS format is quite good because it's very efficient. A vector, you can't get more efficient than that. And to represent all of time, it just takes three things: the start time, the frequency, and the end time, is it? We don't really need the end time because it's regular, but it's just three numbers to represent all of time. But that efficiency comes with some limitations. We've seen it doesn't work with modeling multiple time series, which is especially relevant for reconciliation, and it requires regular observations. The alternative with Civil that we adopt in the Fable package just reuses that rectangular format. So the frequency argument that causes a lot of people trouble is calculated automatically. You probably have seen this before as quarterly data. There's no need to specify what the seasonal frequency is here. Skip a little bit forward. But talking about the window function, a lot of people in the tidyverse and R already know how to slice and dice a time series, slice a data set, especially in a rectangular form, using filter. So we could reuse, without much work of our own, existing knowledge from our users and without having to load them up with domain-specific loading. So if ever there's an opportunity to reuse existing knowledge from your user base, that's a good place to start with designing a framework. So Civil has a lot of benefits and one con. The con is that we store the entire time index, every observation, and that allows the irregular thing. And that's a little bit inefficient. We have to store a sequence as the expanded form. But there's such a thing called alt-rec in R, which allows you to build a sequence from just the sequencing start point and step signs. And that's going to be a work in progress to speed that up. And then there will essentially be no loss, no inefficiency to using Civil objects. Okay, modeling, I'm going to skip through a little bit because Ralph talked quite a lot about this. The ETS model, say, is quite similar, designed quite well because it follows a lot of the principles from stats function. So it inherits a lot of the design that pre-existed. But for a lot of people in R, they're used to using a formula interface, the tilde, to specify the response variable on the left and then the predicting variables on the right. And that's something we wanted to adopt with the Fable package. And lastly, forecast has some inconsistencies where one model just gives you forecast that Rob is now fixing. The alternative in Fable is that we adopt now the formula-based interface. So we have the tilde. On the left, we have the prediction. And on the right, we have how we are predicting the response variable. And one thing to note here is the transformation is on inside the model formula. The difference here with forecast is the transformation is inside the model function. So one of the problems with this was that every model needed to recopy the code for doing the transformation, undoing the transformation. Instead, with Fable, the formula parser does the automatic transformation and back transformation. And we're no longer limited to just lambda for box-Cox transformations. You can, of course, use any transformation either. So use a symbolic computer algebra in order to invert that. And it's built for scale, so multiple time series, multiple models. You might have seen it. This is the decomposition model. So this is composition of different models that I was talking about before. Here, rather than having an STLM model, which takes in or only works with STL and only works with ETS or REMA, which you specify, here a decomposition model is completely generic. So you can pass in any decomposition technique, such as STL. This itself is a model that will be used to decompose the data, and you can swap that out with a different model. And then you specify forecasting models in order to forecast the components. And this was what allowed people, when I first released this, to get a little bit crazy and try many different combinations and do ensembles as part of the forecasting for the components. So that's when I knew that I was onto something right, when people were able to do things that I hadn't considered before. So a few improvements. We're inheriting the interface for modeling from R that people are already familiar with from cross-sectional. We're separating into a composable layout model specification and fitting. That's what allows us to put the model in different places for ensembling and decomposition and other combinations. So I guess one main core tip for developing software and designing forecasting frameworks would be to work with modular components as much as you can with the forecasting workflow, split it up so that you can reuse it in different ways. I will skip through accuracy, but the same approach applies. Here we allow people to define arbitrary accuracy functions and then use them to calculate their own accuracy metrics, rather than in forecast, which has a predefined set that cannot be changed. Okay, lastly, with the forecasts, this is the issue that I was talking about before. If I wanted to change the intervals, the uncertainty of a forecast, I would need to recalculate the forecasts from nothing. And this was quite a pain point because usually we'd want to look at the default forecast intervals, maybe change them a little bit, and that involved quite a lot of computation at times, especially when there was simulations involved. Another pain point here was that a lot of people were using the internal object, and this was actually the recommended way to access the point forecasts. So the way to access the point forecast was $mean. And when I talk about readability for human design interfaces, these point forecasts that we're getting here, even though it's called .mean, isn't actually the mean. Because we've done a transformation, this works out to be the forecast median instead. And this would be completely lost by a lot of the users, especially if they don't have a background in the statistics and distributional theory when you transform a distribution. So as a patch fix, one of my first jobs working on the forecast package was to implement something called bias adjustment. And I now regret the name. I inherited this from one of Rob's blog posts. And what this was doing is whenever we had a median, because we did a transformation, it will do some adjustment in order to actually get the forecast mean. So if I set bias adjust true, I now have the actual mean, even though it still is no difference to the code for accessing the values itself. So that's quite confusing, and I wanted to set out to improve upon that. And this took me down a huge detour of a whole different library of software called the distributional package. And we now have distributions as a first-class citizen. So this allows you to change the intervals and calculate the intervals on the fly. So after I've computed my forecasts, I then can calculate a mean, the median, and the intervals, and many other distributional operations, calculations from them, directly from the pre-calculated distribution. We don't need to regenerate the forecasts now. And by splitting this up, I recognize that the distributional vector that I created here has much wider applications than just the forecasting. I broke it out into its own smaller modular package, and it's now being reused in epidemics, being reused in Bayesian statistics, and also just teaching in general. Being able to see and work with a distribution directly rather than using functions for operating with them has been much easier to teach our students. Okay, so some of the key differences, rather than calculating forecast intervals, we're now calculating forecast distributions entirely. And these are again in the data frame. So people that have used tidyverse or other data frame tools are already knowing how to use this tool object. We don't have to teach them a domain-specific way of working with a fable. So revisiting the fable forecasting framework, each step inherits from the next. So we start with tidying the data with a Sybil, and from the good foundation set up there, we're able to forecast multiple time series across multiple models. And there's visualization tools that we're building on Sybil as well. This estimate step is also modular in its own right. By separating specify and estimate, we're able to split up models and reuse models in different places for ensembling, reconciliation, decomposition modeling. So what's next? I really like what I did with the distributional package to have those distributions. That solved a lot of our problems. And what I'm working on next is doing the same thing for time. With temporal reconciliation, what's holding me back from implementing it is that there is no time class in R which allows you to do temporal aggregation in the same object. So you might start with daily data. In the Sybil, I want it to have daily data, weekly data, monthly data, annual data, all in the same column. And then when you model them, it slices the different granularities to give different models at those granularities. So we've gone quite deep with this one, and we're now thinking about calendrical calculations. Rob worked on a CalCal package, which will be the foundation, and MixTime is going to mix these things together to allow you to put quarterly data and weekly data in the same space. And lastly, for reconciliation, GraphVec is another package that I've been working on. The tourism data where you had region, state, and purpose, I've recently started to believe that these are actually graph relationships, and being able to represent the graph relationships between these time series is not currently possible. So I'm working on a way to relate different values in a vector with each other. So this will enable, hopefully, better time series tools for visualizing mixed granularity data sets. Maybe you've got weather coming in hourly, but sales coming in minutely. You can see and visualize both of them in the same space. And of course, the holy grail of cross-temporal forecast reconciliation, probabilistically. So that brings together probabilistic from distributional, temporal from mixed time, and cross-sectional with GraphVec. Okay, I've got a few open questions here, but I'm well over time, so I'm going to leave it to Tony to add some thoughts and some discussion. And do you have some slides, or you just want to chat?
Just chat. So I have you can be the chair.
Not a problem.
Ask the question.
Do a chat.
Okay, thank you.
Thank you, everyone.
Okay, so any questions?
Yes.
Yeah. About frequency, and sometimes especially in demand forecast, and you do have multi-victim, but 5% predictor not necessarily need to be 12 months, and because of some business processes, 4 months or 3 months, some business process affecting this data.
Yes.
And yeah, that is also, I think it's quite limitation when you provide monthly data. It automatically selects the seasonality 12 to pass through the ARIMA or EPSs.
Yes.
And I think would also be nice in data processing when you're creating an error discipline and to select for individual time series a specific seasonality. Can be, for example, you have 1,000 of SKUs, and then some of them, it's a really monthly data, but the seasonal cycle is different across the time series. I think could this will attach automatic detection for that seasonal request and would improve forecasting more.
Yeah, so in the modeling step currently, we specify a model, and that has some default seasonality that it knows from the data structure, the time vector. And those defaults usually work quite well. You can override them. One thing is that days in a year or weeks in a year, the default is an integer seasonality. That if you're using Fourier terms, you can get a little bit more precision by putting the 0.178 in the weeks of a year to align it better. But to your comment on cyclical structures, if it's changes over a business cycle that operates, that's not currently possible with the modeling, largely because of that first step here. So I talked about the workflow building on top of the foundation of things that came before it. And currently the tidy set with the civil classes of year, week, year, month, year, quarter, they only support regular seasonality. So what I'm working on with the mixed time package with Rob, mixed time will allow you to specify different calendars. So it might be trading day calendars. It might be a university semester calendar. And those can be irregular. Just like days in a month is irregular, you will be able to specify different breakpoints and then apply some seasonal pattern across those cycles.
That's not what I meant. I meant you have monthly data, let's say, but seasonal cycle within the data, it's not 12. Can happen due to the business process.
As in, you've got monthly data, but you might have something repeating every 3 months?
Exactly.
Okay, so that is currently possible. Using month as the foundation, you can set the period equals to 3 months or 3, and then you'll get 3-month seasons.
but not for every data set. Can change across time series. That's what the ignorance is. Like you can attach and automatic detection as individual time series before actually you build it. Yes.
So now it's more about specifier, where you've got multiple time series in a data set, and you want to apply a different model to each time series.
Yeah, it can be because you might have for some specific time series 3 months seasonal. Cycles, and for the others can have really 12 months. It can be one of them a seasonal product.
I think that's perhaps one thing that I should have added to what's next. And it's a great reminder, it's a long-standing issue. The issue here, which is solved by vectorized data structures, is currently the model specification here is not vectorized. And we want a different model specification for different parts of the data. So we need a vector of different model specifications, which isn't currently possible. So that is on the plans, but not the priority. Any other questions?
So the distributions, they are parametric distributions.
And yes,
so
and
wanted to do like quantile regression.
There's empirical distributions as well. And the distributional package itself is extensible. So you can put in any distribution.
I'm curious about the data management. Is our package exposed or do you use some time series database or other types of database to store your data?
Yeah, a lot of R is done in memory. So currently Sybil is all in memory. Again, some of this is limited by the data types that we're working with, the time class. I recently, after making Sybil, the tidyverse has done better database connections. So it's now possible to swap out the data frame in memory to be a database that you can call out to. But whenever you come to the modeling step, you'll need to collect the actual figures and calculate it in memory. So it's technically possible.
So one issue is accessibility, which is awesome. And one of the main use cases is in teaching. So my problem with R generally is the learning curve in terms of data structures and data frames. And if you're extending it in time mix, how much do you assume you know about the tidyverse?
How much do we assume for the tidyverse?
You see what I mean? In terms of a user, if I find that all data frame is not computer science sort of barrier. Yes. How much entry barrier is there to using your code if you come from not having a great?
Right. So I find there's two parts to this. A lot of the people that start to use Fable have already used the tidyverse. So when I give workshops teaching people how to do time series, usually they've already done cross-sectional data analytics, and they've seen at least rectangular data structures and how to work with them. With Fable, you can use non-tidyverse rectangular tools as well. So if you're using regular base indexing, that also works here. But the main core requirement is that they need to understand rectangular data objects, and that's quite more accessible to a lot of people. The Hypergol workflow here, we've found is actually quite easy for people to learn, especially if they don't have a computer science background, because it's compositional. It's telling a story, going through each of the steps of this workflow. As opposed to trying to apply multiple models across multiple time series with a TS object, for example, you need to do your own data management with having list of elements and then doing functional programming across the list to lapply or apply across each value or write for loop. And as soon as we get into those programmatic concepts, we lose a lot of people. So having the model function as handling a lot of the functional programming, a lot of the application across time series and models has made it accessible to a lot of people without the computer science background.
Could we look at your open questions? Because
yes,
if we have some time.
We do have time. Okay, so one of the questions kind of relates to that model, vectorized model idea that I was talking about with Rasul. How do we apply a different model to different time series? This is needing some grammar of how to specify different models conditionally on other attributes. And this also can touch on contextual forecasting that we'll see tomorrow. if we're forecasting holiday, we might use a different model from if we're forecasting business tourism. So we can use additional context to specify more appropriate models. The other element, which is an open question for me with modularity of models, currently in Fable, a model is just one big black box. You pass it into the model function with its specification. It has a train method that takes in the data and returns a model. Can we break apart a model into more modular components so that you can switch out the optimization criterion, so that you can swap out the automatic selection, the hyperparameter selection process? And I've been tinkering with some ideas on how to design that, but it's a whole nother Fable ecosystem beast in its own right. So I'd be interested if anyone's thought about how to break apart a model into smaller exchangeable components. Has anyone thought about swapping? Yep.
No, I have another question that we saw.
I'll start with that one because I'm really interested in some discussion on that.
I remember Headley Weekend, didn't he have these
Tidy models?
tidy models?
Yeah.
That's smart.
I've looked at it. They do split out just as much as Fable does. They don't split out the model itself and the statistics behind it, but they do split out data pre-processing for like bootstrapping the data and then applying it and stimulating from bootstraps. But as far as the model, like a regression model, it's still just a black box of regression without swapping out the optimization function.
Which kind of modular approach we have in model? I mean, in general, modularization with software engineering is one of the best practices. So,
What's the best practice?
modularization.
Yes.
Once more, is the best approach.
So one optimization might be the optimization criterion is maximum likelihood. The likelihood function is this. Can we swap out the likelihood function for a different one? Can we switch out the maximization function for a different routine? Maybe we maximize the accuracy over 7 days ahead rather than 1 step ahead. Lots of different problems that are not currently possible with a black box approach.
So I will talk about that, but I was hoping that you already have the solution for that.
I thought about it, but maybe this could be an outcome from the event. Lots to talk about.
2 or 3 slides, so that people should think about that.
Nice.
Be my
I mean, from an engineering perspective, you could use inheritance or some form of mixing
Yeah,
for classes or interfaces in Java. I think
right.
that would be.
So inherit, yes. You want to inherit from some basic good approach that the model might set out and then be able to overwrite things. But also, how finely do we break this up? Do we go all the way to the likelihood? Do we just kick that under optimization routine? How modular is an important decision that will depend on the context for who you're working with. So I don't want everyone to specify the full likelihood optimization process to do an automatic ARIMA model, but I want it to be available for people that do need to do that. So multifaceted, how do you actually engineer it with inheritance structures or class systems or functional programming? That probably depends on if you're a Pythonic style, an R style, etc. But exactly how you split it up is a design problem across both languages. When's lunch? When's morning? Oh, I was rushing for no reason.
Yeah, and maybe also on that, I think like, yeah, it's very difficult to choose what these modules should be. And I mean, I actually thought about it when you talked about accuracy, right? So because I also implemented something like that. And of course, it's easy to say, and now you have here this function where you just implement your own accuracy measure. But then it's like, okay, I want the maze. So what do I need for the accuracy? Well, I need the forecast, the actual. But then, let's do the maze. Okay, so now we're naive over the whole train set. Now, okay, so where does that now suddenly come from? So like, already thinking about what are all the things people could possibly want to calculate accuracies is very difficult, right? And with the models, it's probably even more difficult to think about, well, what could all these things be that people need for a model?
I mean, there's always a trade-off between generalizations.
Yeah, exactly.
You think you generalize, then you find use cases which are exceptions.
Yes. And the accuracy function from the forecast package does the job for most people. Like, yes, it's not a rectangular format. You can't compose it with lots of things together. But most of the time, people look for an RMSE or an MASE, and it will do that. But if you wanted to do anything more, you have to implement it all from scratch. So in that composition, like what do you need to do an accuracy measure? And something I thought about, this isn't the complete set, it's just the residuals passed in, but you can pass in the actual values, you can pass in the distribution of the forecasts. And I still don't like the design of this. I think there should be other ways to access directly from the fable object rather than some process joined manipulated version into function arguments. So I don't have the solution there either, but I do think it's an improvement to be able to specify functions with the basic inputs that you usually need in order to specify your own procedures.
I think we're running into our morning tea.
Definitely do that.
No, with this. So just final
question. Maybe it's nice because it's a long time I stopped programming in R. That this from the Python perspective, when creating a framework, take decisions to decide what is a data structure that you are going to accept as input, but then which one you are going to use internally. And I want to ask you, are facing similar problem from the Python perspective? Parallels is amazing for the index because it takes for temporal time. That is much slower than using the underlying array, in that case, NumPy. Are you facing something similar into the R ecosystem that you want a specific format as input, but as soon as you have it, you will take the temporal information, the story, and work with a different structure to speed up things?
Yeah, we're pretty strict with data structure in that we require a Sybil. It is extensible so that you can make it work with other data structures, and on the horizon is to make it work with Sybil databases as well. That should be fairly trivial, just collect the results from the database at the right time. But as for the internals, currently with the model being a black box, it can store and represent things however it needs to. There's some elements of like data preprocessing for transforming the data, which I've decided is universal and can not be changed. It passes in the transformed data, and then it gives the model is responsible for producing outputs on that transformed data. And then Fable framework will undo all those transformations correctly. I think there's only one way to do that, and that's why I've not made it extensible or modifiable. You remind me?
The other point, if you are facing that part of like there is a much efficient structure to speed up all the process, even though as an input you just another one, it's much easier for the user.
Right. So on speed, I talked about the time classes with Sybil being slow. Well, it's not slow, it's just inefficient. It has to copy the values, even though they're sequences. And this is not a limitation of the framework, it's a limitation of the use of the framework, where currently the time classes are just the values of time exactly as they are, and that's inefficient. But there's nothing stopping you from swapping out that time class to be whatever you like. That could be more efficient. Use algrep to represent the sequence of numbers rather than the full individual values of the numbers. And everything that flows on from there will just trust and use the sequence however it was set up. So because that's extensible, and as I work on mixed time, I'm going to build out those more efficient approaches. And it's not a limitation of the framework. It's just not implemented for better time classes.
Okay, thank you very much.
Thanks.